Hello guys and girls and welcome to one more video in which we'll be looking at the solution to a quant question which was present in slot 1 of CAT 23 paper. This question is based upon the topic of geometry. Now again, I want you to read the question first. I want you to take your time to understand the question and try it out once yourself before you watch the solution to the question. So this is a question that's been given to us that there's a quadrilateral ABCD which has been inscribed inside a circle. Inscribed inside a circle basically means that the 4 points, the 4 vertices of the quadrilateral are lying on the circumference of the circle. So I've drawn the circle as has been described inside the question, and we have been given a few ratios. That ratio of AB is to CD is 2:1 and ratio of BC is to AD is 5:4. Right, and we have to find out the value of AE is to CE. Now, a general rule of thumb that I tell all my students to remember when it comes to solving geometry questions is that 90% of ratio questions in geometry, which have some triangles involved in the figure, can be solved by applying the concept of similar triangles. Similar triangles is one property or one concept which is present inside triangles in which all the different equations are dealing with ratios. So if you find ratios and triangles together, it is highly likely that the question is a similar triangles question. This question is no different because if you look at the figure, you can easily see that there are at least 4 triangles that you can spot here, 4 small triangles. Of course, there can be more than that if you read the question or look at the figure in different ways. But 4 small triangles at least are there in the figure. Triangle AEB, BEC, DEC, and AED. Now, if we can prove that some of these triangles are similar to each other, then maybe by using the property of similarity, we can find the ratio of AE is to C. So let's try to do that. So first thing is that I am going to be looking at triangles CED and AEB. Now, between these 2 triangles, we will apply one small property of circles here, which gives us equal angles. So that property of circles states that all the angles subtended by a chord in the same arc will be equal. For example, in this figure, if I consider the chord BC, the chord BC subtends an angle BAC at the major arc of the circle. Right? With respect to BC, this arc is a major arc. Right? So on the major arc, the chord BC is subtending an angle BAC. Also on the major arc, the chord BC is subtending an angle BDC. So these 2 angles will be equal and they're said to be angles in the same arc. Right? So angles in the same arc subtended by the same chord will be equal. This property of circles, if we know, then we can apply that to see that angle EDC and angle EAB will be equal as I marked it here. Also angle ECD and angle EBA, angle ECD and angle EBA will be equal. So if these 2 angles are equal, by the property that angles in the same arc are equal, then using that we can prove that triangle AEB and triangle DEC are similar to each other. Now once 2 triangles are similar, we know we can apply the property that ratio of corresponding sides are equal. Now, ratio of corresponding sides are equal. If I apply that, I can say AB by CD, which is given to us as 2:1 in the question, will be equal to BE by CE, will also be equal to AE by DE. So, ratio of all 3 corresponding sides are equal. So, BE by CE and AE by DE will also be equal to 2:1. So, from this, what I can say is that if I take CE as X, then BE will be 2X. Similarly, if I take DE as Y, AE will be 2Y. So let me try to represent the value of C and B in terms of X and D and E in terms of Y. So we can write this. Okay. Now, similarly, moving forward, if I look at triangle BEC and triangle DEA, we can prove that these 2 triangles are also similar. The remaining 2 smaller triangles are also similar. Again, by applying the same property that angles in the same arc are equal. So why? Because the chord AB, for example, subtends both angle ECB and angle EDA. So these 2 angles will be equal. Also, the chord CD subtends the angle EBC and angle EAD. So these 2 angles will also be equal. So again, 2 angles are equal. That makes triangles BEC and AED also similar to each other. Right? Okay. Now, if these 2 triangles are similar, once again, I apply ratio of corresponding sides are equal. So if I do that, I can say BC by AD, which has been given to us as 5/4, will be equal to CE by DE. So BC by AD will be equal to CE by DE. Of course, will also be equal to BE by AE will be equal to 5/4. Now let me just consider these 2. 5/4 is equal to CE by DE. And what I'm going to do is that I'm going to be putting CE as X and DE as Y. So using that, I can prove that X by Y is equal to 5/4. Now once I have X by Y is equal to 5/4, this question becomes very simple to solve because now we have to find out the value of AE by CE. Now, AE by CE is nothing but 2y by x. So if x by y is 5 by 4, 2y by x is how much? That is equal to 2 into 4 by 5. And that gives me the answer as 8 by 5. So AE is to CE will be equal to 8 is to 5. That will be the correct answer for this question. Thank you.